Physics is full of conservation laws. This is the first one we're going to wind up talking about. It's the conservation of momentum. So first of all, what does it mean to conserve? What does it mean to conserve? To conserve means that you essentially wind up with the same amount of what you start with, correct? If you want to conserve your I don't know, energy, if you're a jogger, you try to pace yourself, right? You want to have as much energy at the end as when you started. Well, that's the same thing that's going on with conservation of momentum. Essentially what conservation of momentum is that you have the same amount of momentum in the beginning as you do at the end. To illustrate this, there's a couple ways of illustrating conservation of momentum in physics, either through explosions or collisions. And I'm going to first of all talk about an explosion. So for example, let's take an example of a gun. Okay, and I've got a gun, I've got a rifle here, and I've got a bullet inside the chamber. Now, we could ask, what is the momentum before I fire the gun? What's the momentum of the system in this case, which would be my gun and bullet? Well, let's see. The bullet's not moving. The gun's not moving. If neither one is moving, as you've probably already figured out, neither one has momentum. So the total momentum before I do anything is zero. The total momentum of the gun-bullet system is zero. Now all of a sudden I fire the gun, right? There's my explosion. Kablooey. There's some smoke. And what happens? Now I've got a bullet that's zipping off with a huge velocity, right? It has momentum. It's an object in motion. In fact, it's got a relatively tiny mass, but it's got a really large velocity, right? So that's the momentum of the bullet. Remember, before I fired the gun, my system had no momentum, correct? The law of conservation of momentum says that my total momentum after must equal my total momentum before. So my total momentum before was zero. My total momentum after has to be zero. But how is that possible if I've got a bullet that's flying off with a non-zero momentum? Well, it turns out the momentum is a vector quantity. So notice I've got this big old arrow. That's going to represent my momentum, the momentum of my bullet. I'm going to put P sub B, momentum of bullet. Again, that's a non-zero arrow. And the question is, well, how could I wind up with a total momentum of zero if my bullet momentum is not zero? The way I can still have this work out is if my gun, during the process of pulling the trigger, if my gun acquires a momentum that is equal in magnitude and opposite in direction. And that is true if you've ever fired a gun. What happens? The gun kicks back, doesn't it? You feel it go in the opposite direction with an equal momentum. Notice that the momentum of the gun is going to be a little bit different in that it's a much more massive object, and therefore it has less velocity, which is good for your shoulder. Fortunately, the bullet goes off at hundreds of miles per hour, whereas fortunately the gun does not kick back with the same velocity because it's got a much larger mass. So you can still have an equal momentum. The momentum of the gun is indeed numerically equal to the momentum of the bullet, but it's got a much larger mass and therefore a much smaller velocity in order to give you that same momentum.